Hello everyone, this is Pampi Morandante again, and today I will talk about the graph of a reciprocal function. Here we go. Okay, I have here an example. The table shows some values for the function f of x is equal to 12 over x. And this is an example of a reciprocal function. And our task here is to fill in the missing values here in the table and draw its graph. And for letter B, use your graph to solve the equation 12 over x is equal to negative 3. Now let's solve for the missing values of y. So we have here negative 6, negative 12, e, which means error or undefined. We have 12, 4, and 3. Why this is negative 6? Because just simply divide 12 divided by 2. We have here negative 6.
2, I mean.
12 divided by negative 1, then negative 12, and so on and so forth. What I'm just going to highlight here, why we have here error, because when we divide 12 by 0, so that means undefined in the calculator. So we are putting here E as a representation for that. Okay? Up next is to draw the graph of the function f of x is equal to 12 over x. Now, as you can see, there are only 3 points here in the negative side of the x-axis, which is negative 3, negative 4, negative 2, negative 6, and then negative 1, negative 12. But there are 3 more additional points, which is, this is negative 4. When x is equal to negative 4, we have here negative 3. So I'm making use of numbers that are divisible by 12. So I'm having here negative 6, and that's negative 2, and then negative 12, which is negative 1. Why I'm giving some additional points here? So that we can figure out how the graph looks like. Okay? Now, since we now have more points here, and we know already how the graph behaves, and then we can just simply connect the dots or the points smoothly. Okay, so there you continue graphing. So we have here 0 and undefined. I'm just putting it there to highlight, but we will not do something about it. Later, I'm going to explain to you what do you mean by this. Let's continue with 1 and 12, 2 and 6, 3 and 4, 4 and 3. And as you can see, I'm putting additional points here again here, which is 6 and 6, 2, and then 12, 1. Okay, so let's connect the points smoothly, and that's how it looks like. Okay, what I'm going to show you here is just to double check whether our graph of the function f of x is equal to 12 over x is correct or not. So look at this. This is just how you do that in one of the applications in the iPad. So there you go. That is the graph of the function y is equal to 12 over x. This time, I will talk about the graph. Observe properly. Now, you can see that as the value of x increases, each line gets closer and closer to x-axis, but never meets it. So this is the one that I'm referring to. Okay, see, it never meets the x-axis. Okay, and this is called the horizontal asymptote of the graph. I am making use of the word asymptote. Okay, it is approaching to x-axis, but it's not touching the x-axis. Okay, here's another thing. The two parts of the graph also get closer to the y-axis as x gets closer to 0. So look at this. These are the two parts of the graph. Get closer to the y-axis as x is equal to 0. Remember that when x is equal to 0, that becomes undefined. So in that case, the line never actually meets the y-axis because there is no value for y when x is equal to 0. So that's the meaning for that undefined there. And this is called the vertical asymptote of the graph. Okay? And this type of curve is called a rectangular hyperbola, as it has asymptotes that are perpendicular to each other. So see, look at that. That is what we call perpendicular, when two lines meet at right angle. So that's the reason why it is called a rectangular hyperbola. Okay, last task here is to answer the follow-up question. Use your graph to solve the equation 12 over x is equal to 3.
Negative
so we
3,
are just
I mean.
going to look for negative 3 in the y-axis. Look at this negative 3, and x there is equal to negative 4. Or just simply solve the equation. Algebraically, the value of x there is negative 4. Okay, and that's it, guys. Thank you so much for watching, and don't forget to like and subscribe. Bye!